Hi, this is Vigneshwar. Today we're going to see the k-means clustering assignment. So k-means clustering is basically splitting n number of observations. Instead of splitting, we could say dividing n number of observations into k number of clusters. So each of these observations will be clustered into a cluster which has the nearest mean. So the number of clusters will also be equal to the number of centroids, and centroids are basically the centers of the clusters in which we are clustering the data. If we are done with the clustering, each observation would belong to the cluster with the nearest mean. So initially, to go about this, we are importing the necessary libraries like we are importing k-means and k-means model from the PySpark machine learning library, and we are importing array and square root from NumPy and math, and we are also importing spark conf and spark context. Spark context is basically used to channel all the spark function, and spark conf is used to create an object for the spark context. So first we'll execute this cell. So this will basically give us the version of the Spark context which we are using. So the Spark context version is 2.4.1. So the next step would be to load and parse the data. Dataset which we are going to look into is the iris dataset. So here we are loading this data into this variable called data, and then we are going to parse it. So the each of the columns in the dataset are separated by comma. So hence we are using this line dot split by comma. So we'll execute this cell. So this is a Python RDT parse data, and we'll display just the first 5 rows. So these are the rows. If you look at these, we do not necessarily need all of these rows for doing the k-means clustering. So what we do is we take only the necessary ones. So we use the map function. What we do is we need only the first, second, third, and fourth. So we use float of x of 0, which is the 0th, which is the first one, 1, 2, and 3. So when we uh, map the data in this manner, we get this as the output. So now we are having only the columns which we need. So the next step would be evaluating the clustering by computing the within set sum of squared errors. Since set sum of squared errors is basically a calculation which is made based on the distance between the centroid and the data point, which is also known as the observation. So what we do is we square that value. So the distance between um, the observation and the centroid is the error, and when we square it we get the square error. So we have to compute the within set sum of squared errors. So this is the code for that, and we'll execute that cell. So this cell is executed. So the next thing is the training of the data set. So here the maximum number of iterations is 100 and the runs is 100 as well. So when we run this code, we will get the within set sum of squared error value. So we'll execute this cell. So the within set sum of squared error for the data set is 110.276. The purpose of this WSSE is to group the data points in their respective clusters. So the next set of code is similar to the code which we just saw now, but the only difference is that we'll be looping it. So here also the maximum number of iterations is 100 and the runs is 100, and so this loop will stop until the error value is lesser than the threshold or the maximum number of iterations has been completed. So we'll execute the cell. So these are the WSSE values for each of these clusters. So I guess that's it. Thank you.